Hello everyone, myself Saloni Jaiswal from MC 5th SEM IAPS DAV. Today I am going to solve my set A of first internal test of subject computer oriented numerical methods. Now let us start. Our first question is find the cube root of 12 using Newton-Raphson method correct up to 4 place of decimal. We know that we find cube root of 12, then x cube is equals to 12 is our equation, assuming and x cube minus 12 is equals to 0. Hence our function f of x is x cube minus 12 and their differentiation f dash x is 3x square. So we know that the Newton-Raphson formula is xi plus 1 is equals to xi minus f of xi divided by f dash xi. In this formula we have to put the value of our functions. So after putting the functions, we get xi minus xi cube minus 12 divided by 3x square I. Then we know that cube root of 8 is 2 and cube root of 27 is 3. Hence our 12 is lying between 8 and 27. Then the result must be between 2 and 3. So let x0 be the approx root of 12. X0 is equals to 2.5 and let for the first iteration I is equals to 0. X1 is equals to x0 minus x03 minus 12 divided by 3x square. We put the value of x0. Then we get x1 is equals to 2.5 minus 2.5 का cube minus 12 divided by 3 into 2.5 का square. Then we will get x1 is 2.3067. This is our first iteration. Similarly, for the second iteration, we put I is equals to 1. So x2 is equals to x1 minus x1 cube minus 12 divided by 3x1 square. So here we put the value of x1 in this formula and get this equation. After calculating this, we have the value of x2 is 2.2894. Then this is our second iteration, and for our third iteration, we put I is equals to 2 and simplify it. Then x3 is equals to x2 minus x2 का cube minus 12 divided by 3x2 square. Here we put the value of x2 in this equation and get x3 is equals to 2.2894 minus 2.2894 का whole cube minus 12 divided by 3 in brackets 2.2894 square. After calculating this, we got the value of x3 is 2.2894. This is our x3. Hence, this is our, and also this is our cube root of 12. Hence, the cube root of 12 is 2.2894. This is approx value. Now we have to solve the question number 2. Here we have to write an algorithm for finding square root of 12 using fixed point iteration method. So here is our algorithm. Firstly, we have to read the x0, e and n. Here x0 is initial guess, e is error of root, and n is the total iteration of our convergence. Now second step is x1 is g of x0, and in third step we are starting our for loop. In for loop I is equals to 1 to n. So step of 1 is 2. Then x0 is x1 and x1 is g of x0. Here in sixth step, if x1 minus x0 is divided by x1 is less than equal to e, then go to step number 9 and print convergence of root and end of for loop. Otherwise, we print does not converges to root and going and stop. And print right convergence to a root ix1, and in 10th step we have stop our algorithm. Now the question number 3 is give the output of Gauss-Jordan algorithm for this augmented matrix. Gauss-Jordan is similar for Gauss elimination, but in Gauss-Jordan elimination method, the matrix is reduced to an upper triangular matrix. But in Gauss-Jordan method, it is reduced in diagonal matrix. So here we have applying some operations for creating zero of elements which is below two diagonal. So here are the operation for R2 for row 2. Here R2 goes to R2 minus R1 multiplied by 6 by 10. For after calculating we have R2 plus 0.6 R1. R3 for creating R3 elements is 0. So R3 is R3 minus R1 multiplied by 3 by 10. And after calculating our R3 minus 0.3 R1 is get it, and R4 is R4 minus R1 multiplied by 5 by 10, and after calculating R4 minus 0.5 R1 is. So after applying this operation, we got this matrix. Again we have to performing some operations for this matrix. And R1, firstly we are applying the operation at row 1. So row 1, R1 is R1 minus R2 in brackets minus 7 divided by 3 by 3.8. And similarly for R3, R3 minus R2 multiplied by 3.1 divided by 3.8. And R4 is R4 minus R2 multiplied by 5.5 divided by 3 by 8. And after applying this operation, we got this matrix. Again, here R1 is R1 minus R3 multiplied by 4.4737 divided by 2.4474. And R2 is R2 minus R3 multiplied 0.8 divided by 2.4474. And for R4 is R4 minus R3 multiplied by minus 2.3422 divided by 2.4474. After applying these all operations, we got this matrix. But here is not all the elements are zero, so again we have to calculate some operations. Now for similarly for R1 is R1 minus R4 multiplied by minus 15.6992 divided by 9.9248. And for R2 is R2 minus R4 multiplied by minus 4.3732 divided by 9.9248. And R3 is R3 minus R4 multiplied by 10.3157 divided by 9.9248. After applying these all operations, we got the diagonal matrix. Then we have to find the value of variable x1, x2, x3 and x4. So the x1 is 10, x1 is equals to 4.49.999. So here after calculating this, we have to find we got the value of x1 is 5. And for x2 is 3.8, x2 is equals to 15.20136. Then x2 is 4.00035 and approximately x2 is 4. Now for x3 is 2.4474, x3 is equals to minus 17.1310. So x3 is minus 6.9996 and the approx value of x3 is minus 7. Similarly for x4, 9.9248, x4 is equals to 9.9248 and the value of x4 is getting 1. Hence the x1 is 5, x2 is 4 and x3 is minus 7 and x4 is 1. Here are the values of variables. Thank you.